So coming from the HPC space, and I already see in the chat some discussion on how HPC and other usage patterns and devices are different. We've talked about urgent HPC for a while. We're not seeing it at scale. There are good examples, but it's not pervasive yet. Yet, I believe we're seeing more and more of it, which is, and some of the requirements are different if you think about large systems where the data is available exactly once, and you can't save it at the scale you're getting the data. You better have your workflow scaled up, running, ready at the right time and compute capability. And that's why we think there is a good reason to talk about time-sensitive workflows separately, even though some of the particular challenges and technologies and so on may overlap later. But this is where we come from. Shaun?
Yeah. So I was just writing in the chat then. So just reading some of the comments that were put in, I think time-critical workflows. I really want to make a distinction. Time-sensitive workflows doesn't necessarily mean near real time. There are various aspects to this. I think one of the issues why this is becoming increasingly dominant, at least within the field that I'm working in, is that we're trying to make most efficient use of the hardware that's available. So we don't want to run high throughput computing or Lambda functions on a frontier scale system. But there are certain elements of the calculations where we do want to run on frontier. So seeing as we've got the first slide up, I would say time-sensitive workflows aren't new. They've been around for a long time. They're still under development. You've got autonomous vehicles, all of which are controlled by workflows feeding in from different sensors. Increasingly, the number of sensors on these autonomous vehicles are getting larger, the data volumes are getting larger, and they're all, as Raphael said in his introduction, feeding into AI systems. But they're not the only ones. Ever since the F-16, at least for the US, almost all fighter jets have been aerodynamically unstable. That means you need workflows to make sure that the pilot inputs fit within the aerodynamic capabilities of the aircraft and modify it accordingly. But of course, no workflows are perfect. And this is one of my favorite XKCD cartoons, how you build input into a workflow. So yeah, I guess you all saw earlier this week, or maybe you didn't, there was an article about a Waymo autonomous vehicle that decided to try and take a shortcut into oncoming traffic. So there's still a lot of work going on in this area. So do you want to go on to the next slide? So what's changed since the last time? So I was telling Raphael, I actually had the enjoyable experience of listening to the talks from the previous 2022 session yesterday. There were really interesting talks. And I'm glad to see a lot of the people that were presenting there are here again today. But since then, we've seen the rise of AI and machine learning. And I put NVIDIA. I noticed that Tom Gibbs is giving a talk on this, so I feel justified in mentioning NVIDIA. Because of the time-critical nature of some of the work that's taking place, we're seeing a lot of surrogate models replacing the reduced order models that were there before, simply because it's quicker. They're much faster to give the results. And if you're in a time-sensitive situation, for instance, in an autonomous vehicle, you really need that very fast element. Again, as Raphael said, there's new techniques coming along all the time. What you learned last week is probably irrelevant this week. But at least for the community I'm in, which is Fusion, provenance is important, because if we start using AI ML models to predict the behavior of a device, of a power plant, if we try and use it in a control system, it's potentially a very heavily regulated environment. And the regulators are going to want to see how any AI ML model has been constructed, make sure that it's used the same in all situations. So all the metadata used for making these models is becoming increasingly relevant. Exascale computing in reality, you all know this. We've got the first ones, larger models, higher fidelity, smaller time steps. I'm going to come on to this later, but actually executing this through workflows can be hampered by multi-factor authentication, which is becoming increasingly common. Heterogeneity was a big theme in 2022, and I think it's still a big theme today. I mentioned NVIDIA at the top, who are really the dominant players in the AI/ML marketplace. But there's still Intel and AMD out there. We still use a lot of x86. Increasingly using cloud, we've got ARM, CPUs, a whole raft of things. There's an increasing interest, at least again, with the diffusion community on near real time, but leveraging all of those things that I've mentioned above. And in many cases, a lot of these things are requiring integration with digital twins. So I'm doing a presentation on this next week, 3 weeks time at the SOFT conference, and I can't remember what SOFT stands for, except it ends in fusion technology. But there's a lot of work going on to feeding your inputs into a digital twin, predicting the output, comparing it with reality in order to take some control mechanism or for a design of experiments type use case. And any experimental downtime is money. And finally, federation.
I put federation there because the rest was already there when we discussed. So we heard that from Raphael just a moment ago. Code mobility is becoming a requirement for more and more use cases. Federation here can mean federation of existing systems or federation of systems under one control for geographic separation in the interest of resilience. And that creates cross-facility data dependencies that users would like to forget and often can't. And I don't think, especially in the high volume data HPC space, people did not expect data mobility that was not explicit for them. So they said, I need my data from A at B before running. It was always explicit. And I think we need to, especially in a time-sensitive fashion, we need to take that into account very much in the substrate. And that's a new thing in the last years. Yeah. Shall we move to the next one? I think we're very much stretching our time budget.
Yeah, just skip over this. Just shows increasing complexity of the workflows that we're starting to use and the fact that we're using more and more tools and more techniques.
We can look at this in our breakout session. If you don't have the time to read it now, that's fine. Yeah. Come into our session and add your favorite logos, which we're missing. Next one. So the on-demand access. So that's the urgent computing part that I mentioned. And we already noticed there's two ways of looking at time sensitive, right? Is it time sensitive from the need to compute to starting or finishing, and time sensitive inside a workflow where some data needs to be obtained from a source or needs to be processed because the data availability is the issue, or the time window in which you need to have the result. And we will talk about MFA or other authentication options, I think. Data movement, large files from exaclass systems. So I see Bruno here, Destination Earth will produce a petabyte a day consistently. That's quite a bit to move around. You don't really want to. And then there's the small file versus properly HPC ready file structure discussion that we all fear that AI brings with it. The provenance checking, knowing which data was used to train a particular version of a model, knowing which results were generated from a particular model, and being able to track that possibly in a regulated environment over decades. Fusion is one. Those devices live long, but life science is similar. Drug checks and why were they permitted, which tests went in there, which predictions were used. And data access and data movement policy controls. Now, in the US, that may be less of a topic. In Europe, it's a very difficult topic because despite unified regulations on many things, which are hard to understand, in many cases, there's even national regulations that contradict or are on top or underneath the same. So even a lighthouse project like Destination Earth, again, this is an issue to be discussed, but think about health data, where every nation has their own requirements again. And then you want to federate or use other resources.
And I'm putting in a plug in there because although I work for the UK Atomic Energy Authority focusing on fusion energy, we will not be the people constructing power plants. That will be done by commercial organizations. So all of this data access, data sharing within a workflow, and this workflow may be couple elements from different commercial suppliers. We need to make sure that IP rights are protected. And I would highlight, again, you're right, Europe. I highlight this because, of course, Brexit happened in 2021, and the ripples of it are still being felt in the UK and across Europe, I feel.
For sure. So let's move to the next one. We have a few ideas, and I think those are mainly to get you interested in contradicting us or confirming and giving better ideas on top of it. For the 4 topics from the last slide on access, how do we do a tested execution? Maybe with trust bundles. If you don't know what that is, let's discuss. How do we federate identity and access management? Maybe programmatically to get around multi-factor hurdles in a safe way. For data movement, I see 2 different ones. One is inside a workflow where we want maximum performance, but we don't want to reinvent the coupling middleware with every project or every community. And across sites, that's, again, how do you identify which data you are looking at and how do you get it moved smartly? Shaun, maybe the other 2 for you?
Yeah, so confidence tracking, again, a lot of this is already included in workflows by default, but particularly when it comes to object stores and AI models, how do you track the provenance of those? Would you put your AI weights inside Git? Would you use the HPE Common Metadata Framework? So shout out for HPE for open sourcing that. Very good.
I did not put that there.
That was me. That was me. Data access policies, again, is highly dependent on the granularity and the rules that are in place within particularly geographic areas. How do we guarantee secure access to object stores? I don't know what FAM, you put that one in.
So that's fabric attached memory. So that's even higher performance, even nicer in some sense, but completely out of the security models that we typically see other than POSIX style, which clearly is not enough in many cases.
Yeah.
And so that's
I think that's all we had. If you're interested in any of those topics, let us. Oh no, more topics for discussion.
No, I think this is essentially the highlight, the section things we had in mind for our discussion. More examples. The usual discussion about unifying workflow management solutions. I see some people who own a solution, so maybe they want to be unifying things. Portability. It's a summary of what we had on before as topics for the discussion.
Yeah.